I come from the User Supporter group. We're so happy to have you all here with us tonight. It's going to be a really exciting evening. Just before I pass you on to Phil from the Agile Roundabout, a couple of housekeeping issues. If you need to go to the bathroom, we've got 2 sets of toilets on your left-hand shoulder. And if we have an emergency, which fingers crossed we won't, the emergency exit is on your right. So hope you have a nice evening. We'll be floating around if you have any questions. Thanks again for coming, and I'll pass you on to Phil. Thanks.
Thanks everybody for coming tonight. For those that don't know me, I'm Phil from TRG. I run a software engineering and agile recruitment business. About 9 months, Rob and I decided that we were going to set up the Agile Roundabout as a way kind of to give something back to the community. We were hearing a lot of similar stories across industry, and I thought it would be worthwhile setting up something where people can share those. Tonight we're very lucky to have 3 great speakers from 2 organisations. We've got Sean from Equal Experts. We've known Equal Experts for a while. They provide very elegant and simple solutions for some quite complex business problems. And also we have Will Perkins and Charlie Wilkinson from River Island, who are on a very interesting technology journey of their own. So hopefully it's going to be really interesting, and yeah, thanks very much again to Courtney and Lorraine at YNAP for letting us use this good space, and I'll pass you over now to Sean, who's going to give you his talk. Thanks.
Hi everybody. So the deliberately inflammatory title of this talk is Every Code Coverage Tool is Measuring the Wrong Thing. But the actual sort of more sensible title of this talk is just sort of a deeper dive into code coverage, and just sort of talking a little bit of how it works the way it works and why it doesn't work other ways. So this is me, I'm Sean, that's my Twitter handle. Like I said, I work for Equal Experts, that's our logo. Let's get started. And the first thing, show of hands from the crowd, who here has used code coverage before? Good show of hands. Who's using it right now? No, you're in a talk. But I assume you used it today, or very recently, which is great. Anyone, just shout out, why do you use it? Okay. Anyone else? Yeah? Okay, that's a good one. Sometimes the answer to that is because my boss told me to. and that's okay too. But the 2 sort of answers were, to see how well my code is covered, which is sort of circular, but we're not marking this in the test, so that's okay. And to see if I missed test cases, which is a very real thing. But the usual answer is something like that, something like my boss is making me, or something like, where I work, we want to know how well our code is tested. Did we miss anything, but also, is it well tested in general? Is that about right for everybody's experiences? A couple of nods. Okay. And yeah, I mean, that's a good answer. Code coverage is good. Testing your code coverage is good. A lot of times, how it's done is not so good. Show of hands. Has anyone here ever been annoyed by code coverage? Few hands. Anybody ever been annoyed because someone wants to talk to them about code coverage, or what the number is today, or anything like that? Few more hands. Well, that's not your fault. That's because I think maybe the team was using code coverage in the wrong way. And it might be impossible to use it in the right way, so that kind of matters. And this is a thing I hope most of us can get behind. And it's not that we're using this thing, I'm not saying it's evil, but sometimes how it does things affects how we use it. And if we know how it does things, that can help. So let's get back to that starting point. Starting point is, how well is our code tested? This is what we call a qualitative measure, because well is like sort of continuous and not very discrete, and maybe even emotional, and there's multiple axes to compare it on. It's a qualitative measure, and computers don't do qualitative measures. Computers do quantitative measures, things with numbers and comparisons and maths and stuff. So, is there a way we can take this question and modify it a bit so that it becomes a quantitative measure? And then we can usefully answer it with a computer. Because right now, how well is my code tested is kind of like, does my website look good? Which is a really important question. But who here has had any success writing a computer? Who thinks they could write a computer program to tell you if your website looks good? Yeah, no hands. So, a quantitative measure. Sorry, quantitative is one of those words that's different in North America. So I might screw it up. It's a quantitative measure. So here's one. How many lines of code can I delete without causing any test to fail? And the usual caveat emptor applies here. Lines might be statements or methods or branches, and if it doesn't compile, the tests fail, obviously. So this is one measure. It's not the only one. Another one is, can I change a statement without making a test fail? I use that one sometimes. If any of you ever submit an offline code review to Equal Experts, I probably shouldn't tell you this, but there's a phase when we mark that, where we replace string constants in the code with the word giraffe and see if everything still passes. And if it does, we yell at you. But how many lines of code can I delete without causing a test to fail? That's a decent measure. Now, why is it a decent measure? Well, it's a pretty direct translation of the qualitative question. If I can delete a whole bunch of my code without causing my test to fail, then my tests probably aren't testing that code. In fact, they're definitely not testing that code. It makes sense, but the third one's the key, because it minimizes the code that's written for the set of tests. And one of the important things about KDD is that it prevents gold plating. And so this helps. If you've written more stuff than you need to build the app, you might be using WebSphere, and you should not do it either way. So this would be a really good measure, and in a perfect world, this would be a great way for code coverage engines to work. Just sort of delete lines at random, and if the tests still pass, complain. And nobody does this. Can anybody guess why? Because it's expensive. Really, really, really expensive. I'm going to show you a sample bit of Java later on in this presentation. It's got something like 23 statements that you could potentially remove, and that's excluding things like import statements and throw clauses, but just 23 statements. And if I was to use this method, I would have to perform 506 build-in test cycles, which I'm not going to do because these guys have to present in like 20 minutes, and I don't have that kind of time. So that's what we want to do, but the truth is, we can't. We can't afford to. So, what to do instead? We cheap out. Or, to translate that into professional speak, like everybody at the office is always telling me to do, we find a lower cost approximation. So, we need a quantitative measure on a budget. So, instead of how many lines of code can I delete and still having all my tests pass, that gets changed to how many lines of code are executed, statements, methods, branches, when all of the tests are run instead. So, this is not as good, but it's cheaper. It's a lot cheaper. One test run that's slightly slower than normal because the code has been instrumented, instead of potentially hundreds or thousands of test runs whenever you change something. And it's approximately the same thing. But we've got one of those little asterisks there, because all of the fun happens in the word approximately. So, at first glance, they would seem to be almost exactly the same thing. But they're not. Anybody off the top of your head, can anyone just raise your hand or shout out, have any suggestions as to when they might be different? little bit of that, but like some examples of something that if you deleted it, it wouldn't run, but it doesn't get executed during a regular test run. Like, so that's sort of the difference. There's a hand over here as well. What do you got? For an idea?
The fact is, if the line was run, it doesn't mean that you verified that the code is doing what it should be with that code.
Well, yeah, that's sort of besides the point. If you can delete the code without making a test fail, you're also not doing that. But some examples of things are, who's ever had to put a try-catch block into their code to keep the compiler happy? Anyone? A couple people. Anyone ever have to write, anyone have a class with all static methods? Helper class sometimes? A couple of those. You got a constructor on that class? Yeah, like a private constructor to make sure the class never gets instantiated because it's only got static methods. So something that never, ever, ever runs, right? So that's there, and it's there for a reason. And your code would break in a way if it wasn't there, but it doesn't get executed. So stuff like that tends to cause real problems. And here is a real-world example. And a real-world example, I mean something I kind of copied and changed so it's not, you know, not sensitive. So, class, first of all, up here, it's complaining on line 13. And that is because this class has only static methods, and the JVM generates a default no-argument constructor. So this isn't even like a line that I can delete. It's just there because the compiler puts it in, and it's only static methods. It never gets run. It shouldn't get run. If you write a test that constructs an instance of this class just to exercise that constructor, you are a fool. This catch exception on line 18 and 19. Every JVM ever, well maybe not next year because of last week, but every JVM ever has SHA1, the message digest value in it. It's the rules. It can't call itself Java if it doesn't. So that will never ever not be there. The compilers will know that, so you have to catch this stupid block with, you know, something like an assertion error or a throw error. That will never ever get thrown. And if I delete it, it won't compile. My code coverage engine complains. Then down here, I've got, you know, my no output stream extends the output stream. I've got a method that has to be there to extend the output stream, but it never gets executed. And it's, you know, when you've got comments like do nothing or ignore this or just catch this exception, those are usually the times. But did anybody spot the other one? Anybody? Okay, let's see. What about this line right here on line 23? Anybody see that? I wonder what that is. It's a really stupid method that I put in to make a good example. It does something really dumb, and then it throws away the result. And this is a classic example. If I deleted this method, and deleted its calls, nothing bad would happen, and no test would fail, by definition, because it's nothing but a side effect. And a good code coverage, the expensive code coverage method will catch this, your cheap one will miss it, and there's stuff there that just doesn't need to be there, and it's not going to find it. So that's really what I'm talking about. And you can see how the one method keeps you a bit more honest than the other method. So, problem areas. Synthetic methods. Everybody know what synthetic methods are? Okay? Things that the compiler puts in to keep you handy, like you know, in value methods and things. Things you do to make it compile. In general, if it was a feature that was introduced in Java 7, it would probably break a code coverage engine. ARM blocks, automated resource management blocks, are a classic example of that. Because they don't have one branch, it probably puts in about 6. Just for trivia's sake, it turns out that an ARM block does null checks even if it knows that the answer can't possibly be null because the people that were generating it says, oh, it's no problem, the JIT optimizes that away, which it does. Nobody cares that they're there, except for your code coverage engine, which just throws a giant tantrum. And as we just saw, useless code. There are no code coverage tools that call themselves code coverage tools on the market that I know of that even attempt to detect useless code. But in a way, it's the most important thing you could use help with. So, learnings. They're all flawed. Some of them are really, really, really flawed. But the bottom point is the one I'd like you all to take away, if you can. In that example, with the spurious method, with the fake method in there, code coverage was 83%. I counted it. When I delete it and improve everything by deleting a method that doesn't do anything, and isn't covered by any test, or isn't mentioned by any test, doesn't affect any test, when I delete that bogus code, code coverage drops from 83% to 69%. That is actually one of the biggest implications of using code coverage in the real world. Because of situations like that, you cannot reliably enforce either of those two rules, with one exception. You can't say coverage always goes up because somebody could refactor some code and get rid of useless things and make it smaller and reduce duplication, and test coverage can go down. You can't say it's got to be at least 85% because you can go from 86% to 84% the same way. So you can't do anything about that unless coverage level is 100%. If it's 100% and you delete some untested code, it's still 100% because everything that's there is still covered. Now, most people here have probably heard someone complain about 100% as an unrealistic standard. And you're probably right most of the time. So you can't use, what this means is that if you're using code coverage enforcement like a tool like Sonar or something, or code coverage enforcement as part of your build, sooner or later, you can't guarantee that it won't do something wrong on you. And this is why probably people in this room have had a conversation about code coverage that they didn't really want to have, even if they were doing the right thing. So, what do you do instead? What I like doing is spot checking. So on my projects, I don't enforce it as part of the build. I will either run code coverage regularly as part of the build and keep a look at sort of the long-term trends, but ignore short-term dips. Or I will, if the coverage is high enough and the gaps are low enough, keep kind of a mental catalog of the places it's not covered, and in a small enough code base, just kind of have that in my head and check them out every couple of weeks to make sure that it's still sort of what I'm thinking of. Or, as a colleague of mine named Steve says, don't use the data as data, use the data as a starting point for a conversation with someone. Is this, did coverage go down because we did something good? Did coverage, and it's just a blip, did coverage go down because we forgot to test something? And you just sort of use it as an emergency check. Compared to last week, not to last commit, you know why it goes down. One thing you can do is with the right build system in a larger project, especially if you're on a brownfield project that you're cleaning up and improving the test on over time, separate into silos of completely tested code and completely untested code. Just keep them in different source trees in the same project. If you're using something like Gradle, compile them together, and just split them. And then, once you have an area that is completely tested and can be completely tested nicely, enforce on a 100% rule. That's really the only rule that's ever worth enforcing. So, two more things. One is the question everybody asks me whenever I give this talk. Should I test coverage and exceptions? Of course not. Unless they do something like non-trivial. But delete ones that aren't called. Delete ones that you can delete without making a test fail. I'm a big fan. I'm an IntelliJ user myself, so I always watch when it declares a highlight. This code isn't called. You can always create them later. There's no sense creating them early. Just create them as they're needed. Be refactoring continuously, red, green, refactor. Don't create them early because you'll know you need them. You'll be wrong. Now, the second one should I enforce 100% code coverage? And the answer to that is it depends. And the real answer to that is most of the time you probably shouldn't. But twice in my long and reprehensible career, I've been on teams where we were kind of pretty close to it. The last time was maybe in 2013. And like I was describing, we did spot checks sort of every week, every 2 weeks, and we had sort of a usual group of suspects, 4, maybe 6 sort of places where things were never covered and it was okay not to cover them. And once I had a little bit of extra time, and we put in some explicit tests of the kind that normally you wouldn't write, like constructing a class that doesn't have any instance methods just to satisfy things, just to see if we could get up to 100%. We could. A week later, we were still at 100%. So I chatted with some of the people on the team, and we just sort of had a conversation about it. Like, not an imposition, but a bunch of us were like, should we actually try making this build fail if it's not 100%? And no one was really sure, but we kind of decided to try it and see what happens. Because we had been like at 98, 99 for a while. So we turned it on, and we forgot about it. And maybe 3 weeks later, the build broke, somebody committed something, code coverage had gone down from 100% to 99%. And the person on the team looked at it and went, oh yeah, no, I totally forgot to put a test there, and we wouldn't have spotted it without the test. So we decided to keep it, and it was just sort of mostly there, it wasn't a big deal, but the first 3 or 4 times we triggered it, it was something we had forgotten, and it was reminding us and helpful to us, so we decided to keep it. And then the only other really time it came up was, the client we were working for, there was a management change, and someone from a different division came in, and they were sort of asking us about our quality of our code and how good the application was. And so they asked the usual questions, and someone sort of like, well, what's your test coverage? I have no idea how good it feels to, without even looking, just go, oh, it's 100%. And when someone asks you how you know, you just go, oh, well, we configured the build to fail. And it's just like, very, very smart. So it depends on why you're doing it. If you're doing it because you think it's helpful for you versus if you're doing it because someone's boss's boss has decided to impose this rule. It depends who decides. If the team decides for themselves, I believe it can be a good thing. And if it doesn't feel like work, if it feels helpful, I think that's a good thing. If it's just there to tick a box or because someone's imposing on you, it's probably the wrong thing. But it has occasionally been the right level of tolerance for me before. So that's what I've got on code coverage. Anybody have any questions? Yeah?
Is it about this approach, delete some lines and then check if everything is okay? Do you know about qualitative tests?
Pardon?
Qualitative tests.
I can't hear you, sorry. Mutable tests. Well, do you mean like the mutability detector?
Because a couple of weeks ago I was on this meetup and guys said about this mutable test and compiler changed the code of
Oh, mutating tests, yeah. Yeah, some of those are an excellent stopgap in for that, and it's similar to what I was talking about doing with sort of code coverage submissions. That can help. I have not used it personally. I've talked to a few people that have, and it's sort of, you're going to have a couple of problems with that. The first is it will, I think a lot of those do sort of, the short answer is use them, right? I think what a lot of those will do is do some statistically random mutations as opposed to brute force everything mutation, which is what you want to really enforce coverage, but they'll still catch stuff, so it's good. Things like Scala test in the Scala land, and there's Kotlin ones as well will do that for sort of inputs as well, like brute forcing massive amounts of inputs to catch sort of cases that you haven't added at all, like, oh, you forgot to deal with negative numbers here and stuff, so mutating the code as well, pretty helpful. I suspect that if you're going to add one of those to an already existing really large code base, you're going to run into there's no way you can perform all of the mutations at once sort of thing. So it probably works a bit better if you start from nothing and every time you add a line, it checks that it can delete it and then sort of maintains it over time. I don't think they're perfect, but it sounds like mutation tests sound like a pretty decent approximation to this, or another way to tackle the problem. Yeah. Do you have a question?
Just
the
same question actually. Mutation test.
Cool. Yeah.
Do you think that's being setting a high standard for code coverage is a sort of run the risk of encouraging potentially poor quality tests?
Absolutely. So, I mean, related to all those rules is I can't think of a time I've ever set a standard, set a number. So I've set, equal experts, we tend to set very high standards for quality of testing, very high standards for, performing test-driven development correctly and properly, and that tends to result in very high coverage numbers. But I can't think of a time we've looked at this and said this number isn't high enough. Because you're probably exactly right. And in practice, what happens with, to be honest, Sonar is not one of my favorite pieces of software. And the reason is, psychology-wise, what you measure is what you improve. So if you measure test coverage, not value delivered or money made by the company or time to ship or defects reported in production or anything like that, if you measure code coverage, people will make that number go up. But realistically, they'll make that number go up at any cost and sort of just that number, not the related things that you think are going to come up with that.
Without necessarily understanding the reason that you're getting these.
Almost certainly. For example, in a related, sort of thing, if you pay people or tie people's bonuses to number of bugs discovered, they write crappy code so that they can discover the bugs. It's been proven many, many times. So be very careful about what you measure. And this is why I hate Sonar, because Sonar measures everything. It reports everything. And so it just sort of scattershot random improvements. It's not a good way to focus a team on something. So, but the answer is, picking a number is a bad thing to do. I've never seen a number, and I wouldn't really know why exactly 84% is magically better than 83%. Good code tends to have high numbers. Yeah. Sort of the inverse. Well, insofar as that's kind of what I do, I mean, I don't really count them so much as inspect them. But yes, I mean, it is sort of the answer. It's kind of the same thing, right? Because 99% coverage is 1% done coverage. But at the same time, sort of going over them all and saying, well, this branch isn't executed. Why is that? Is it because we're missing a test? Or is it because we've not written this properly? We're not testing this properly? And looking at it and deciding and maybe even making a note there is good. Yeah. And I tend to do it sort of on a case-by-case basis if coverage is high enough. I mean, that's the other wonderful thing. If your coverage is generally high, it's easier, at least, to individually go over the bits that aren't covered. If your coverage is 50%, you're never, ever going to do it, because that's half the code base you're looking at line per line. You're not going to do that. But yes. 36 branches not covered. Like, yes.
This has been quite interesting, actually, because I kind of understand 100% code.
Yeah.
Code coverage will go down,
Exactly.
so I might do it. So I've been a bit resistant. I'm having testing team approach me and ask me when I'm going to publish code coverage statistics to the wider business. And I don't really have an answer to it right now, apart from I don't think they need to know, and it needs to be to use the tool. But that what you are is a very good reason why I don't think code coverage should be looking at a metric that needs to measure code quality.
If you're looking for a better metric, by the way, another metric that you could consider is the ratio of well-factored test code to production code as a ratio. And in practice, people like ThoughtWorks, in my experience, sort of between 2 and 3 to 1 is a good ratio. So if you have 10,000 lines of production code, somewhere between, maybe between 1.5 and 2.5, so between 15,000 to 25,000 lines of unit test and acceptance test code that's as well factored as the production code is a decent ratio. If you have 10,000 lines of production code and 4,000 lines of test code, that's not so good. If you have 10,000 lines of production code and 100,000 lines of test code, that's not so good either. So that's another ratio or another metric you may want to use, and it's nice because it covers sort of over-covering, which tends to be some very brittle tests that are poorly factored, tests that will just break as soon as you touch anything. Where were we? We were talking about sort of just sort of counting the numbers. So the problem with that, well, I mean, so the one difference is if you delete code that doesn't do anything. Well, actually, it's kind of the same thing, right? Because if you add a bunch of code that doesn't do anything, that number doesn't go up. And in fact, that number would have gone down as a ratio to your total code base, right? So if I accidentally add a class that I forget to call, nothing really happens. So it has sort of the same flaws. It's maybe a bit better, but really it's sort of when you start looking at them and you know what the rough areas are, it's sort of a know your code thing as opposed to focus on the other thing. Yeah?
You mentioned a little bit code coverage, but there's other analytics like the cyclomatic complexity, things like that. Is any value on those?
So there is some value in cyclomatic code complexity. It suffers from the same sorts of problems at the sonar suite level, right? Which is that people will start doing ridiculous things to make it work. I can show you afterwards, I don't have it on the slide, I can show you an example of decent code that has a lot of branches in it and has a very, very high cyclomatic complexity that doesn't, actually maybe I can describe it, but this might not work. If you've got a bunch, if you're transferring the contents of one bean into another bean, and you go sort of, if bean A dot first name doesn't equal null, bean B dot set first name bean A dot first name. If you do that with first name and last name and address and postcode and anything else, and if you've written or generated a very simple sort of property-to-property copier that only performs the copy if the field's not null, those null checks, any method like that will end up having a cyclomatic complexity of like 50 or 75 or a couple of hundred really, really quickly. But really it doesn't because the ifs don't depend on each other. So it's an okay measure, I guess, but like all okay measures, you can come up with fairly trivial examples that make it seem like nonsense. But the bigger problem is that you can have low complexity code without it really being good code because it's sort of cheap to calculate, cheap to find a path through. I mean, honestly, it would be the same advice, right? If you find methods or classes with really high complexity, take a look at them, know why they have that high complexity, and know that they have either for a reason or because it's one of those examples that fools the test, or, oh yeah, this is on our list that maybe we should rewrite. Okay, well, thanks everybody. Oh wait, yeah. So ratio of test code to production code is probably, I would say that's a better metric. And in part it's a better metric because it can be both too low and too high. It's still not perfect because you could have 2.5 to 1 ratio of just horrible tests that don't test everything. But if it's well factored and you know that the tests are good for other reasons, it can sort of give you a measure of, oh, is this tested well compared to the industry average or tested less well? But other than that, so it's a better average. Things like lead time, how often the build is broken, recovery time when the build is broken, those are sort of metrics that have real impact on your team, so they're not so much metrics as actual measure. The best one is always since we started developing this software, does the company make more money? But that can be kind of in a way. It's the ultimate metric. It can be kind of hard in a large company, especially, to actually attribute that right down to the code. But I mean, that's sort of the Agile principle, right? Like if we make money doing this, if we deliver value, And money's a decent proxy for value. It's delivering value, if you go back to the manifesto, is what it's all about. So metrics that are closer to value.